Rhino. I'm going to open Rhino, and Rhino's going to take a minute to open. So if you got your computer open, find Rhino and hit open. First, it's going to make you wait while it updates its toolbars, help files, template files, and all that junk. Because at least once a month, the university sends updates and everything slows down a whole bunch while it catches up. So, only click Rhino once and wait. Seriously, wait for it. You keep clicking it, you're going to open multiple copies and you're just going to wait longer. Because it takes 6 times as long to open 6 copies as it does to open 1. And none of them will do anything until you get through one of them. So, you're going to get a bunch of pop-up windows, like the usage statistics window. Oh man, okay, don't ask me that. I don't care what you do when I'm not looking. This license dialog window here, it says dongle not found. It's for Rhino CAM. CAM is computer-aided machining. We have a CNC router in the basement, and we need computer-aided machining software to prepare files for that. You don't need it. So you can just hit OK, and then hit OK again. And then just wait for it to prepare its plugins, and check, yes, I have read, and I accept, and wait for it to do all its things. And Rhino will open. Yay, with some other things that I never want to see again. So I've got this Flamingo getting started window. I'm going to uncheck the box that says to show me this, because I don't want to see it. I'm in. You're probably still trying to get in though, right? Are you still trying to get in?
The computer's still updating.
See? That's alright.
Start.
Oh, let me show you what I did. I click sometimes without explaining. That big white thing on the left side of the screen there is the machining operations browser for Rhino CAM. Don't worry about it. Exit out. You don't need it. But it's going to automatically launch. You can just exit out. Also, because we did not do the license dialog for Rhino CAM, when you try to save your Rhino file, it's going to say that it can't save your stuff because you were working in demo mode. It's saying that it can't save your Rhino CAM stuff. It's going to save your Rhino file. So really, if I draw something and try to save it, it's going to say, could not save mill data because you were working in demo mode. It's okay, don't panic. You're not doing anything with mill data, so you don't need to worry about it. All right. Yay, we're in Rhino. Check it out. Rhino looks a little bit different than the SketchUp, right? Yeah, it's a little bit different. First, I'm going to do this thing. I don't know why our projectors don't fit the whole things and screens and stuff. Hey, can we see the whole thing now? Yeah, all right. You can see the word file. You can see over there. Excellent. Here we have Rhinoceros. Rhinoceros shows you 4 views by default. It shows you the top view, the front view, the side view, and a perspective view. Those are your orthogonal drawings and a perspective view. So you know how in SketchUp you kind of work or move around in that one window and you choose views from that window, and you can model from the kind of perspective view. Rhino does not like that. You can, but it's really hard for you to predict what's going to happen from that window. It likes you to think about things like you're doing them on paper in that front, right, side view perspectives. So if I wanted to draw like a floor plan, I would do it in the top view. That would be me looking down at my paper from the top, right, at the floor. You do not have to see all 4 windows at once. If you double-click on the label of any window, it will maximize that window. Yay. Most of the tools in Rhino, if I double-click on it again, I'm going to go back to all 4 views. Most of the tools in Rhino are buttons. So there is a toolbar of buttons on the left side here, and starting from the top down is the arrow, by the way. I want you to read what it says. Cancel. The arrow is called cancel. I know that's really weird. It is also the selection tool. But it's called cancel because anytime you start one command, you have to cancel it to get out of it if you didn't use it. Alright, so at the top of the screen up here is some words, a little blinking cursor, and it says command. That's the command prompt. Most CAD programs have a command prompt, so you don't have to know where the button is or know where the menu option is. If you know what it's called, you can just type it. So, on the left over here, I can choose a rectangle. I click on the rectangle, and you see up in the command prompt it says rectangle. So I could have just typed rectangle, but the button's easy to get to. The command prompt also prompts you through what you're doing. So, right now it says first corner of rectangle. Hey, it wants to know where to draw the rectangle. Where do you want the first corner to be? That you can define that corner by coordinates in X, Y, and Z, or you can pick a place on the screen. I usually like to draw things at the origin, which is 0. So the origin is where X, Y, and Z come together at 0. That is where the red and green line on the screen are. And if I type the number 0 and hit enter, my rectangle will start at 0. And then I can tell it like how big I want my rectangle to be. So now it wants the other corner or length. Hey, I'm gonna give it a length, like 12. And then I'm gonna hit enter. And then I'm gonna give it another length, like 10, and hit enter. And now I have a 10 by 12 millimeter rectangle. Hey everybody, how often do we work in millimeters? Never. No, because we're American.
America. Where only we know what 1/4 divided by 3/8 is.
Anybody know what 1/4 divided by 3/8 is?
No.
I was kidding. I don't know that one either. So, I messed up. I caught myself working in millimeters. I need to be working in inches. So I'm going to go to File and New. I'm not going to change that. Save that. And I'm going to pick a template file. Small objects inches. Hey, how big do you think the 3D printers print? Big or small?
Small.
Small. So we're going to use small objects inches. Alright, so the grid on the screen there changes. All the units change. I want you to know there's a bunch of ways once you're in a file to change the units of stuff, but it does not change the units of everything unless you open a new file in those units. And you'll get weird things, like you'll change from feet to inches, but the thing when you measure stuff will still give you the answers in feet and millimeters and stuff like that. So you want to be working in a template file that is the right measurement system. This template helps me out a lot when you bring me your files. So the grid is inches with 1/4 inches in it. I'm going to look at your screen and know how big stuff is. Because you're all working in the same grid, and I don't have to measure things. I can look at it and go, oh, that looks like it's about 1,600 feet across, and it's only supposed to be 4 inches. And I can see that because of the grid. You can work on the grid like graph paper, you can snap to the grid. The grid's primary function for me as your source of help is to look at it and go, oh yeah, well you've got that drawn way too big. You guys have been drawing in feet and inches, right? Alright. And now for 3D printing, you're going to draw things at their output scale. The 3D printers have minimum sizes and stuff. There's stuff you can't print. If it's too small, the printer won't print it. So let's start with no wall thickness can be more than less than 0.05 inches thick. I'm going to ask you a math question you're not going to want to hear. Hey, what's 6 inches at 1/16 of an inch equals 1 foot scale? What's 6 inches if your scale is 1/16 of an inch equals 1 foot? If in your real model your wall is 6 inches thick, how thick is it going to be at your output scale?
Less than 0.0. Less than 0.5.
See, so you got to work on this math dealy. You have to. Because you're going to have to lie in your design to get the printer to print what you want. And you have to calculate your lies. Or you spend hours and monies wasting your time printing things that won't actually print. So you got to figure this out. All right, so the answer to that is half of a 16th is a 32nd. What's 1 divided by 32? 1 divided by 32?
30 seconds.
0.032. 0.03125. That is less than 0.05, and you will not be able to print a 6-inch wall at 1/16 of an inch equals 1 foot. How wide is your interior wall? You guys drew buildings already, right? You got interior walls?
No.
How thick are they?
6 inches.
You can't print it that skinny.
Not 6 inches.
Your exterior walls should be about 12 inches.
Yeah, so you're talking about inches.
Glass walls are 6 inches. Exterior walls are 1 foot. Floors are 1.5 foot.
So what I'm getting at here is you're going to have to remodel your design for printing. That's the challenge here. So, if you can't print a wall that's less than 0.05 inches wide and you don't want to do the math, then you need to draw the wall at the printable width in Rhino. That's all. It's 0.05 or more. So hey, how thick are your floors?
1.
I love the array of numbers. They're all about a foot thick, generally speaking. All right, which would make them about a 16th at our output scale.
Yes, did you say how thick your floors are?
1.5 feet.
Yeah, 1.5 feet, so 18 inches.
Yeah, 1.5.
Room for utilities in there, a really big span.
Yes, must be a big plenum space in the now.
Oh, I just want to make people measure stuff now. Anyway, I'll stop torturing you with scale, but it matters. So you're going to be able to bring your SketchUp file into Rhino, and you're going to be able to scale it, or you'll be able to scale it in SketchUp and import it into Rhino. Rhino will import your SketchUp model. You will need to save your SketchUp file as a SketchUp 8. So you'll save a copy of it, and where it asks you for the version, you'll need to choose SketchUp 8. If it's any newer than that, Rhino will not import it. You're not going to lose anything. No program has really changed anything significantly since like 1998. It's still there. And really all you need is like kind of the mass of your building. Alright, so briefly I'm going to show you through a really simple modeling. I'm going to show you a couple things to understand about modeling. And I'm going to show you how to export a model for 3D printing. So first, I'm going to draw a box, which is like a rectangular solid or like a cube or something. So I went over here to the rectangular solid cube box there, and I'm just going to draw it. And I'm going to make it like 4 inches by 4 inches by 4 inches for fun. Ooh, there it is. Notice that everything is in a wireframe right now. And it's all at weird places in the screen. I'm going to mess it all up on purpose. I'm going to right click on this button right here. You see this button? Puts everything in the window so you can see it. It's like find my way home button. Alright. I'm going to click in the perspective view, and I'm going to click on this button right here. It's the shaded viewport button so that I can see this thing shaded like a solid object. Hey, it's a solid object. When I click on it, it highlights. Over here on the right are some tabs. One, there's the Help tab. The Help tab is very helpful. when you pick a tool, the Help tab will help you understand what that tool does and how to use it. There are also about a gazillion tutorials. Don't jump right into random people's YouTube tutorials. Look at Rhino's learning how to use Rhino tutorials so that you don't jump into the graduate level Rhino on your first moment. You can't just Google Rhino tutorial. You could get all kinds of really crazy things. And you're trying to figure out how to draw a cube right now. All right. So I got that cube, I selected it. Over here is the Properties tab. The Properties tab tells me something really important. That is a closed extrusion. It's closed. And that means solid, it means watertight, it means there are no gaps, flaws, and everything is joined together into one closed object. I'm going to use the explode command on that. And now that command prompt, although nothing has changed in my geometry, the Properties tab now says I have 6 open surfaces. I cannot print open surfaces. So, a 3D printer needs to be able to tell what is the inside and outside of closed objects, so it can print inside. Does that make sense? Like it prints inside of stuff, so it needs to know what the inside is. A two-dimensional plane has no inside or outside. It is a two-dimensional theoretical piece of geometry. And so the printer can't do anything with it. Yes?
How did you explode this?
I typed explode, or you can use the explode button, which looks like a little explosion over here. But remember, if you can remember the word, just start typing it. Now I'm going to tell you something that makes me a really serious dork. I tend to sit around in my house in a state of semi-drunkenness going, I wonder what's under the letter K. Are there any commands that start with L? When you type a letter, you get a list of things that start with that letter. And I like to look at that going, wow, I've been doing this for 10 years and I only know what 3 of those things do. I should probably click on what leader is. You know, I know what a leader is, but you know what I mean? Like, I literally just play in this soup. I would never expect anyone to actually know everything about Rhino. And this is a real truth. You ready? There is no one that knows everything about Rhino. It has over 14,000 commands documented in it and 6,000 secret commands that programmers left hanging in it like Easter eggs that aren't documented. Type words and see what happens. Sometimes it knows what you mean even though you're wrong. It does. It has like a thesaurus back there. It's like, are you sure you meant you wanted to draw a... And it'll kick out a list of things that it thinks you might have been shooting for. But hey, can't remember the whole word? That's fine. You don't even have to type the whole word. When I type EX, I get everything that starts with EX and I can click on explode. Alright, but also, once it says explode, I can just hit enter, it's explode. Here's how Rhino will confuse you. You ready? I'm not doing anything, right? I'm gonna hit enter, and it launched the explode command again. If you right click, it will do the same thing. While you're not doing anything, while you're not in a command, right clicking or hitting enter are the same thing, and they bring back the last thing you were doing. So hey, drawing lines, end a line, you want to start another line, just hit enter to start another line, or right click to start another line. It can make it really easy to keep a cup of coffee in one hand and keep right on going, because you can just keep right clicking and left clicking and right clicking and left clicking.
You said it ends with what you just did?
Enter and right click will do the same thing, which is enter. But if you hit enter, while you're not doing anything, it'll launch the last command you were doing.
Okay.
If you have launched a command, it's not going to let you do something else. So you gotta read this command prompt. Every time you click on something, you need to read that thing and see what's going on. Right now it says command, nothing, nothing's going on. But sometimes you can get really stuck in a command and then be trying to draw a line or something or select something. It just won't let me select this thing. Why can't I select this thing? And it's because I'm in a command that won't let me do it, and I need to escape or cancel that command before I can go on to what it is I want to do. Alright, so now I want to pull this surface off this box so I can look at this box. Oh man, it's a big empty box. It's a big, empty, two-dimensional nothing. One of the greatest confusions that I encounter is the difference between grouping and joining. So, grouping is a selection tool. I can have this surface way over here. I can group all of these together, and now they're all one group, and anytime I click on one part of it, I get the whole thing. It's a group. It's a selection group. That's not the same as making them all one thing. It's still 6 open surfaces. They're just grouped together so that when I click on one, I select all of them. Joining is like the process of gluing the seams together. In fact, we'll call it gluing some seams together. Or welding. Welding is a common term for putting the seam of 2 pieces of material together. If I select this whole thing and I join it, join looks like 2 puzzle pieces stuck together over there. Right there. Joining is like gluing or welding those seams. It will only work right if there are 0 errors in those surfaces. Meaning, the corner of this surface and this edge of this surface touch each other within a 10,000th of an inch. There can be like no error in the drawing. So, if you're in the practice of drawing surfaces as individual 2-dimensional surfaces, you're going to want to get away from that practice and start thinking about sticking to just solid things the whole time. Because when I draw that box to begin with, it is automatically a solid. But if I draw an individual surface, I'm going to have to be really careful about making it into a solid that I can print. But hey, fun. Here's what we're really going to do. We're going to make a box. It's going to be a little tiny box. I'm going to start at 0. I'm going to make it 1 inch by 1 inch by 1 inch. It's a cube. It's so exciting. So exciting. So when I click on that box is a closed extrusion. Great. I want to 3D print my little cube. I need to export it correctly, but first I need to make sure that it's that. So I'm going to go to File, and I'm going to export the selected object. So if I have a bunch of things in my file, but I only want to export part of it, I'm going to select what I want to export and choose Export Selected. Use that. Don't use Export with Origin. It'll put the origin in your STL, and if it's too far away from 0, it won't fit into the 3D printer's printable area. Because it'll put 0 in the printable area, and if you're 6 inches out of there, it won't fit. So Export Selected, I need to create an STL file. Stereolithography, STL. Man, I love to talk about stereolithography. It's like the longest misnomer in the history of technology. Hey, does anybody know what lithography is?
Printing?
Never heard the word lith before? Huh?
Is that a thing?
Yeah.
Yeah,
There are also megaliths and monoliths and
Like stone?
yeah. Stereo stone writing. Anyway. I look at this word and I'm like, man, who used that word? Although lithography is a common term for printing, printing's origin is in carving into stone. That being said, we need this STL file. I'm gonna choose STL, I'm gonna give it a name. I'm gonna call my box Bob. Tell it where I want it. Okay, put it there and hit save. There are tolerances you can set. 0.01 is fine. But in this STL export options window, there is a checkbox I want you to always make sure is unchecked. The Export Open Objects button. If you export open objects, you won't be able to print them. But here's the booby trap, you ready? The printer will make you think it's gonna print it. It will. It'll show you a preview, it looks like it's gonna print it. It'll give you a time estimate, and it'll give you a material estimate, and it'll let you go all the way to the end of everything before you find out you didn't get that object because it was open. So, unchecking this box will make Rhino check your work for you. So I unchecked that and I hit OK, and my command prompt up here says it was successfully written as bob.stl. Great. If I mess up this box, I'm going to explode it to mess it up. And attempt to export it again. That's Bob's. Until the tolerance is fine and everything's okay. It will tell me that the STL file I am saving is not adequate for creating rapid prototyped parts. It just told me I was inadequate, which I'm really tired of hearing. And it'll even let me export anyway. But I don't want to export anyway. So, what's wrong here? This thing is open. If your Rhino file is really messy, if you do this if you model really sloppily, if your things are two-dimensional and weird, it can take a long time to figure out what's wrong and fix it. If you directly import your SketchUp model, and attempt to print it, I will refuse to service you. The average SketchUp model takes me 6 to 8 hours to fix. SketchUp does a terrible job of closing things right. And usually it requires the complete redrawing of the SketchUp file, which is really hard for me to do for you because I have no idea what the thing is. So I'm learning every single thing in your building to try to figure out what's wrong with it. You already know all that stuff. Alright, so that STL, yay, it's an STL, great, is what we're going to be taking to the 3D printer. Kind of. You are going to need to stop in the Bear Lab first. We have 8 3D printers and a whole lot of you guys. And a mess of upperclassmen and a pretty serious mouthful of graduate students, and lots of people use the 3D printers. Grad students are crazy about it. So they get really busy. Like, when is this due? Like, May?
May 2.
Hmm?
May 2. Oh, you're talking about this
Yeah.
project? Oh, I thought.
Yeah, sometime in May. All I'm saying is, that last week before it's due, it's going to be really hard to get your hands on a printer. Because that's the last week before everything is due. And you need to make a reservation. In order to make a reservation, you're going to need to come down to the Bear Lab and process your STL in MakerBot Print. MakerBot Print, I'm going to show you really quickly in a second, is the software that takes this file and turns it into a printable object. Not fix your model. What the 3D printers actually read are individual layers. So there's another piece of software your STL file has to go through to make a MakerBot file. The MakerBot file gets loaded into the MakerBot. So, Model in Rhino. Export as STL. Import into MakerBot Print. Process for printing. You are going to need a flash drive. You know, thumb drive. You know, the great data loser. Where's my flash drive? Damn it. Somebody's got my flash drive. I don't know who. I have this one. No, but really, 2 weeks ago I handed someone my flash drive for a second. I haven't seen it since. It's got a bunch of stuff I really need on it. So if you see a flash drive called Stansberry, just give it back to me, please. This appeal is never gonna work. I'm never gonna see my baby again. You need a flash drive. The printers are in no way networked. The only way to load your file into the printer is with your flash drive. The flash drive port on the printers is sort of recessed in a hole. So your rubber alien flash drive or your big fat weird flash drive isn't going to go down in the hole. So it's going to have to be a relatively ordinarily shaped flash drive. Alright. I've had lots of people have problems with rubber monkey flash drives and stuff. Like, can't get those things in there, man.
A normal flash drive.
And, you know, a relatively normal one.
Yeah, okay.
You know, although I like big, clunky, awesome ones, I think they should all be about 4 inches bigger. So we could keep them. Alright, so. MakerBot Print looks like this. It is not on the computers in the computer labs yet. Maybe next year. So I have 2 computers downstairs in the Bear Lab with MakerBot Print on them. You can download your own copy of MakerBot Print, but we won't make you a reservation until we see your MakerBot Print file processed in our faces. I'm going to tell you now, 3D printing is not Star Trek magic. Stuff takes time. So you know that little 1 inch by 1 inch cube I just made? It's going to take about a half an hour to print. It's going to take about 15 minutes to get the printer set up, another 10 minutes to take it down. So we'll call that an hour. It's going to take about an hour to make that 1 inch by 1 inch cube. Yes, that means that your little building, but heads up, how big is your building? 20/16 by 20/16? By how tall?
No more than 6.
Come on, give me your answer.
60.
60/16? Oh, it's about this big. Little baby
Yes.
thing. Little tiny thing. It's not like giant. You may want to refer at some point to how much you can do in the printer. Don't ask me how big the printer prints. I don't remember. I'm going to do exactly what I'm going to say right now. Google it. Anytime you ask me how big the printer prints, I am going to Google it because it is some weird number I cannot remember. It will not stick in my head. It's about 6 by 8, but that's not accurate. Alright, so MakerBot Print looks like this. I'm going to open it. Great. I'm going to need to select the correct printer. We have the Replicator Plus. That's my printer. Alright. And I'm going to go to File, and I'm going to insert a file. Oh, I'm going to insert this file. It's not a cube, I know, it's like a snake thing. In fact, the file's called Snake. It's an earring. It's kind of small, though. It's kind of weird. But the grid we're looking at here and the little box it's in are the printer's printable space. So that's where it's going to print in the printer. There are buttons on the right here. There's a estimate and preview button, a model information button, a print settings button, an arrange button, an orient button, and a scale button. So arrange is about telling it where to move stuff. Clicking on that button again closes that. I don't need to tell it I want to move it over here, I can just move it over there. But you can import a bunch of different things into this space. And then have the thing automatically arrange them so they're not overlapping each other and stuff. Scaling. You don't want to figure this out after the fact. You want this right the first time. So the scale needs to be the scale. And right now it's in millimeters. But it's fine, I just want to make this 200% bigger, if that's okay with this thing. So everybody can see what happens. Hey, do you see that this thing floats mostly in the air? It doesn't lay on the table? 3D printers are like hot glue guns. They're almost exactly like computer-controlled hot glue guns. So what happens when you try to like write your name with a hot glue gun in the air? You make a big sticky mess, right? Because you got to print it on something. That is one of the major design problems with 3D printing is we need to think about this. How do I squeeze liquid plastic into the air thing? So I'm going to go ahead and do my estimate and print preview. I just hit that button. It is going to think about it. The bigger your files, the longer these processes take. Your cube would have been done by now, but my weird snake, the thing's going, it's a weird snake. I don't want to do it a weird snake. And then it produced a preview. And it's in green and it's in yellow. And you see it printed some stuff to support the things that are floating in the air. It prints support material. The support material is the same material you're printing with. And it has to be broken off later. So hey, now that I've done this, I see that this is going to take about 30 minutes and require about 5.4 grams of material. That's not so bad. I can now make a reservation. You'll turn around to the desk and be like, I need to reserve a printer. There's my time, it's 30 minutes. And we're gonna go, great, we'll give you that printer for about an hour. And if it's due, if you need it right now and there's one available right now, hey, we'll put it in the calendar and give you one right now. But remember, there's only 8 of them. And how many of us are there?
Too many.
A lot more than 8. So what we're going to do later this week is we're all going to actually print. I'm going to come to your class, I'm going to take you off in groups, and we're going to actually print little cubes. To teach you how to set up the printer. Then you're going to work on your models. You're going to bring them down to the Bear Lab and do this MakerBot print thing, find out how long it's going to take. Make a reservation. And you'll export. Down at the bottom is the export button. And give it a name. Making a snake. And it exported my file, and that file is a .makerbot file. That's the file you're going to need at the MakerBot. So you're going to end up with a Rhino file, an STL file, which is going to be called something weird on your computer when you look for it. It'll be called something like a certificate trust list. And when you click on your STL file, it won't open. You have to import it into something. So Rhino file, STL file, and then the .makerbot file that you're going to need at the MakerBot. Now the MakerBots. You are going to need to spend money. We do not charge you for using the printers, but you have to buy your own material. The small spools of material, they're about yay big, are $20 down at the Bear Lab. So it's going to cost you about $20, but you are not going to use that whole spool of material, so you may consider sharing, but remember this. You can't put one spool in 2 printers, right? So you can't share and use it at the same time. And you will end up needing it later, but to briefly agitate you, that spool of material is biodegradable and must be protected from light and moisture at all costs, or it will disintegrate on the spool sitting on your desk. So it's a biodegradable plastic material. It smells like maple syrup when it's printing. Don't eat it. It's biodegradable. It's not non-toxic. It's got that fake Burger King pancake smell. I don't know what causes that smell. I'm sure it's a cover-up of the toxic fumes it really smells like. So, you'll need to buy a spool of material. You'll be checking out a print head, a build plate, and buying material. The print heads are $200 each.
Do not lose them.
And do not break them. So now I'm going to give you the only rule of 3D printing. See, you notice I'm not making you sign anything, right? Alright. If you bring it back broken and you do not tell me, I'm going to fine you the $200 replacement cost. If you bring it back broken and tell me so that we can figure out what went wrong together, it will cost you nothing. Alright? But do not return it damaged and expect to get away with it. The last person that successfully printed will get burned for that. Alright. We'll go over how to take care of it and what to really do with it. Also, remember there's a lot of us using a bunch of things. Nobody can... We're going to check you out a print head. We're going to check you out a build plate. The late fines on those are $100 per day each. So you will reserve them for appropriate amounts of time, and you will return them on time so that the other people in your class can use them on time. Got it? Alright. Otherwise, I fight hard to not charge you guys for printing, and I fight hard to not make you buy your own print heads. But I have zero budget, and that means that I can't replace them when you kill them. Printing is notoriously patience demanding. It's inconsistent. It is, what's the word I'm looking for? Undependable. There it is. Undependable. You have to be there with your print, making sure it is behaving properly. Otherwise, all kinds of terrible things can happen. Sometimes prints break loose from the table, and that causes the printer to just print into the air. That can kill the whole machine. That's a $3,000 gee, I didn't actually pay attention to what was going on accident. You kill the whole machine. Right. So you have to keep an eye on them. I'm not saying you have to sit there the whole time going, it's gonna be okay. But man, Samaya. Hey Samaya, can you hear me? No, I'm trying to talk to you.
Oh,
Can you hear me?
sure.
How many times did you print your building facade?
Oh, 10 times.
How long did it take?
5
Each
to
time.
8 hours a piece.
Huh?
So 5 to 8 hours a piece. So
50 to 80 hours of printing? I like to call 3D printing a hobby. It's not an output method, it's a hobby. Alright, it's a thing that you have to become intimate with before you become successful. And that's why we're doing this. You guys probably need these guys in a couple minutes, don't you?
Yeah, what's the scheduling window? How early, how late?
So you can keep the printers overnight and stuff like that. You just have to deal with checking out, reserving, checking out, returning, all of that stuff during the regular Bear Lab hours, which is 9 to 9 Monday through Thursday, 9 to 5 on Friday. I mean 10 to 9. And like what, 11 to 5 on Saturdays when we're open now? We trimmed off that first hour in the morning, stuck it on Saturday. I'm still confused. Alright, so This week in class, I'll be popping in and we'll be making cubes. Yay. Or you guys can do that. You guys can do that, right? You guys make cubes for me? Oh, come on. It's a cube. You'll probably teach them even more awesome stuff than that.
How much time do you need for that to make a cube?
About 3 minutes. So I was just saying you guys can just make them open up Rhino, cruise a cube, and export an STL. I will then come on Thursday and Friday. I need to take them to the printers. In half groups.
Okay. So on Tuesday and Wednesday, you come in to show us how to make the cube, and then Thursday and Friday is printing.
Yes.
Okay. And you said on Tuesday and Wednesday is you said like 15 minutes max or 30 minutes. Or?
Yeah, it won't be much.
Okay.
I will keep that light. And I might send Mary because I actually teach class on Tuesday and Thursday afternoons.
Okay.
But it's alright, it's not a big deal. So hey, don't let any of this terrify you. All you're gonna do is check out a print head overnight and return it tomorrow. It's not gonna cost you anything. But if stuff goes wrong, really, we need to figure out what is wrong so that we can make it better. And if no one tells us, that mouse will sit broken on that computer for the next 5 years. So, see you soon.
All right. Thank you.